Okay, now I just noticed the print quality on this one is pretty poor. So I'll try to explain to you what they say as we go through them. So this is the last half of section 3 too. So it's just proofs, and these are supposed to be lines. So down here, the version of Word that existed when I made these notes, not the same version of Word now. It did not. That's that. I figured out that's what the problem is. They don't translate well from one version to the next. Which you would think if you made a product to replace your old product, that things would actually still work on the new product since you're the one who made it. But go figure. All right, so we're gonna do a whole bunch of proofs this morning. So we'll see what we've got. So we're given that AB is parallel to EC. Okay, so we'll show those parallel. That BC is parallel to EA. So I have to do a different number of arrows to indicate that's a different set of parallel lines. All right, so that's what we're given. We're trying to prove that angle 7 is congruent to angle 4. So we've got to start out using one of those two angles. And I'm a big fan of corresponding angles. So I'm going to start with, okay, I know that angle 7 is congruent to angle 5. Because parallel lines cut by a transversal imply congruent corresponding, and I know that's super messy, angles. Okay. Then we're trying to get from 5 to 4. Well, I can go straight there because we learned all the theorems. So I can just say that angle 5 is congruent to angle 4 because parallel lines cut by a transversal imply congruent alternate interior angles. And like up here, let's just go ahead and say it's okay. On a test, don't do it, but you know, shorten it to CORR for corresponding because you're going to be writing this so much. But I'm trying to show that 7 is congruent to 4, but we're going through 5 to get there. So we just said it. Angle 7 is congruent to angle 4 because of the transitive property of congruence. Remember, you only substitute numbers. Don't call that a substitution. You can only substitute equal values, not congruent shapes. Okay, next up. So M is parallel to N, and we've got to show that the measure of angle 8 plus the measure of angle 3 is 180 degrees. All right, so let's start out talking about one of those two things. So maybe we start out up here at the top because we know that the measure of angle 8 added to the measure of angle 7, we know that's 180 degrees. Okay, because that's the linear pair postulate. So that gets the measure of angle 8 in here. We could say that angle 7 is congruent to angle 3 because that throws in angle 7 that we're working with in step 2. And it throws in angle 3 that we're going to need to prove something about because parallel lines cut by transversal imply congruent corresponding angles. Okay, now if those angles are congruent, we know their measures are equal because that's the definition of congruent angles. And then if the measure of angle 7 equals the measure of angle 3, then I can take and plug that right there, and then it looks just like this. So we don't even have to change the order or anything. So the measure of angle 8 plus the measure of angle 3 is 180 degrees. Now that is a substitution because the measure of angle 3 is a number. It stands for some amount of degrees. So it's fine to say substitution there because it actually is. It's just you don't want to mess up and say substitution when you mean transitive property. All right, so this one, let's fix this. These are segments, both of those. Quit working. That looks good. And it looked like a segment back down here. Okay, so we've got our big picture over here. So our givens, we know that AE is parallel to BD. Okay, so we got that. We know that angle 3 is congruent to angle 4. All right, so I've marked up what I know going in. And we're trying to show that BD, okay, so BD is going to bisect angle EBC. All right, if that's the case, that's angle EBC, right? To show that, we need to say that angle 1 is congruent to angle 2. So that's our goal. We're trying to get to the point where we can say that angle 1 and 2 are congruent. Because if we say that, that's going to follow along with the definition of an angle bisector, how it's a thing, a ray or a line or a whatever that comes through and cuts an angle in half, or creates the two congruent angles. So let's see how we want to start. So I need to have 1s and 2s come into play because this is where that's my goal. I'm trying to get there. 3s and 4s are already in play. So how about we do this? Okay, so here's our two parallel lines. Here's our transversal. So why don't we go ahead and say that angle 3 is congruent to angle 2? Because when parallel lines are cut by a transversal, that implies congruent corresponding angles because those angles sit in the same spot. Okay, so now we've got 3 and 2 in here. All right, so I could do, so angle 3 is congruent to 4, 3 is congruent to 2. That lets me know that angle 2 is congruent to angle 4 because of a transitive property. Okay, so 2 is congruent to 4. So I've already got that marked up. All right, so we need to get angle 1 in there somehow. Ooh, here's how. Let's use a different transversal. So let's go and look at this transversal instead of the other. Because if that's the case, then angle 1, that's not what I wanted. Angle 1 is congruent to angle 4 because those are alternate interior angles. So we can come in here and say angle 1 is congruent to angle 4 because parallel lines cut by a transversal imply congruent alternate interior angles. Okay. And so, again, we're trying to get to 1 and 2 being congruent. That's our goal. So I can get it right here with a transitive property. So now I can say that angle 1 is congruent to angle 2 because they're both congruent to angle 4 with a transitive property of congruence. And if that's the case, then I can say that BD bisects angle EBC because that's the definition of an angle bisector, is that it creates those two congruent angles. Okay? I hope you feel the same way I do, that the longer we go in geometry, the more fun the proofs get. Like, I think at the beginning, you're proving such simple, and I guess you're proving simple things that just make sense. And I think those are harder to prove than stuff that you gotta, like, walk through some steps for. Like, this is the chapter I think the proofs start getting really fun. Okay, let's see how this is supposed to look. These are supposed to be lines. So, actually, down here it looks like they're rays. But I think they were supposed to be lines. Let's put arrows here, because everything's a line. So, I mean, I guess we could do it with a ray and it wouldn't make much difference, but Yeah, they were supposed to be lines. All right, so let's mark up what's given. So we know that AB is parallel to EC. And if I haven't said this already, I think one of the most crucial parts of figuring out how to not solve a prove, but prove something is by marking up the diagram. Like when you mark things, like anything you mark, you should have a step that shows what you marked. So like as you mark it, you write it. So we already had it written in the given, so you mark that down. But if you figure something out, you're like, oh, I know this is congruent to this. As soon as you mark it on the diagram, you go make that a step. I know this is congruent to this, and you tell how come you knew it. We know that BC, this one is parallel to EF. Okay. All right, and let's see what we're looking at. 3 and 4. So we need to throw in 3s and 4s. Okay. And we got to make those add up to 180 degrees. So why don't we... what do I want to do first? God, there's so many different routes I could take. I'm trying to figure out which one would be the most efficient, or if they're all kind of the same. I think I'm just going to start down here with a linear pair postulate. Let's go measure of angle 1 plus the measure of angle 4 is 180 degrees. Okay. So I've got something, like I have this, I just have the measure of angle 1 where the measure of angle 3 is. So if I could figure out that angle 1 and angle 3 are congruent, then I'd be set. So let's see how we get to there. So angle 3, I know is congruent to angle 2. Okay. Because parallel lines cut by transversal imply congruent corresponding angles. Okay. Do you want to... Let's just go ahead and do in that, because I don't want to write that reason down again. Let's go angle 2 and angle 1 and just put this all in the same step, because that's the exact same reason angle 2 and angle 1 are congruent. So if angle 1 and angle 3 are both congruent to angle 2, then we know that angle 3 is congruent to angle 1 by a transitive property. And then that way, the measure of angle 3 equals the measure of angle 1, because that's the definition of congruent angles. And then I can go back up to here, plug in the measure of angle 3 where the measure of angle 1 is. With a substitution, and I've got it. And then we double check, was that the exact order? Yes, so I don't need to change anything around. Okay. All right, then we got one more. What's this fifth one doing? Okay, these are all segments. They look like segments there. Okay, let's mark it up. So AE is parallel to BD. So we've got that written in the given. We've got that BD. Okay, so when this BD runs through, it bisects angle EBC. Now what that tells me is that angle 1 and 2 are congruent. But I have never written down that angle 1 and 2 are congruent. So I have to write that. But I knew it because of the fact that that's what an angle bisector does. So this is because of the definition of an angle bisector. Okay. Now, let's see. So let's look and see. We need angles 5, 6, and 2. Okay, so 5, 6, and 2 need to all come into play. And let me go ahead and do this. Angle, or no, not angle, but AE parallel to BD. So I've got my two parallel lines right there. So I need 5, 6, and 2. I think I want to do I want to do that? How about we do this? What if I say angle 5 is congruent to angle ABD? So this whole angle right here. Because when parallel lines are good. Bitransversal. We know that that implies congruent corresponding angles. All right, so I want to do that because I need to get a sum in here somehow, and that the measure of angle ABD is equal to the measure of angle 6 plus the measure of angle 1, because that's an angle addition postulate. Oops, just pretend like that looks like normal letters. Okay, so then I've got the angle 6 part. All right, I want to have an angle 1 replace an angle 2. Oh, here we go. So right there in step 2, I can come back now and say that the measure of angle 1 is equal to the measure of angle 2 because of the definition of congruent angles. And then I can take where the measure of angle 1 is here and replace it with the measure of angle 2. So that's just a substitution because I'm plugging in numbers that are equal. Okay, so now I've got this whole side here is done. And I've got to make it be congruent to angle 5. But back here on step 3, I said that angles 5 and angle ABD were congruent. So I can say that the measure of angle 5 is equal to the measure of angle ABD. Because again, that's the definition of congruent angles. And if I say that, then I can plug a measure of angle 5 right there. By doing another substitution. Ooh, I like that proof. That was kind of cool. Okay, I'm looking at, I've got my notes out from earlier years. I'm trying not to look at them while I'm going through, but I just noticed I only did 7 steps the year I did this. The last time I took notes on it. I threw this step and this step into one step because it was the same definition of congruent angles. But this morning I didn't notice that I needed it until I got in at a different spot. So I didn't put them in the same step. So as long as you say, everything you say is based on stuff you've already said and know, then we're good. Like proofs are kind of cool. They just follow your train of thought. All right. So your homework, or not homework, you're going to do it in class. And speaking of which, we probably need to talk about homework. I mean, I know you don't really do any because you work so hard during class, but if you ever want some, we can start doing math. I ordered a math counts book to get us ready for math counts this year because I want you to go to a competition or two. I got to talk to Mr. Bird about travel. He says we can do math counts, but we haven't talked about the travel part because it's not something that you do here. But anyway, if we ever want some homework, we can do math counts homework so that you're practicing up to compete later, because I'm not going to lie to you, Ethan, even if you've never been to a math tournament before, I think you got a shot to win the whole state. I really do. But we're going to have to work at it if we're going to make that happen. So I started yesterday. I ordered the book, and then I've never done math counts except for when I was in 8th grade. Like, I actually competed in math counts, but I haven't done it because I always taught high school. So I was the math team coach, but math counts is a little different than most math tournaments. So yeah, I gotta look into it and see what all it entails and talk to some of my friends who have done this before and make sure that I know how to get you prepared. But anyway, you let me know if you would like to start having a little bit of homework, but have it be math tournament level homework. And I also found some stuff online. If you're interested, they teach an online class to prepare you for math counts. And I thought that might be something that you and your folks might want to talk about. It's through the Art of Problem Solving, which is just the greatest math resources of all time. But yes, we need to talk about this sometime when we've got time. So one day during, I don't know, one day when there's a lull in the action in 4th period, or during break if you wanted to run in here, let's talk about that, okay? All right. Let's turn it off.